All right, folks, we are on to my favorite lesson of the quadmester in this case because I get to sing the entire lesson. So I hope you guys don't get sick of me. We're going to learn the quadratic formula. So the first way that we learned to solve a quadratic equation was just by isolating the variable, getting x all by itself. The second way was by factoring and then finding the x-intercepts. And today is the exciting method of the quadratic formula. So here's a quadratic formula. Looks like x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And unfortunately for you, I sing it every time I write it. I sang it so much in my house that when my son was 8, he started singing it. So if an 8-year-old can memorize the quadratic formula, you can memorize the quadratic formula. So this formula will find the roots. Don't forget the roots are the same thing as the x-intercepts or the zeros of the equation ax squared plus bx plus c equals 0, where a is not equal to 0. If a equaled 0, that would get rid of that whole first term, and we would be left with a straight line. So we always add that in where a can't be 0, because this is going to be a quadratic. And b squared minus 4ac is greater than or equal to 0. B squared minus 4ac is that stuff under the square root sign. Don't forget, yesterday we talked about we cannot have a negative under there. If there's a negative, then there are no x-intercepts. There's no solution to the equation. So b squared minus 4ac has to be greater than 0. Let's look at an example. Solve the following equations using the quadratic formula. So these are both given to you in standard form. I'm looking to find the x-intercepts. If it was factorable, we could factor it. Well, let's just see if it is factorable. Can we find two numbers that multiply to 3 and add to 4? Yes, there are two numbers that definitely multiply to 3. They would be 3 and 1. And those do in fact add to 4. So this actually factors to x plus 3, x plus 1. So I know x is going to equal either negative 3 or negative 1, because if I put either of those into those brackets, it would end up being 0. So I know my answer is going to be x equals negative 3, negative 1, but I want to see if I can find that answer by using the quadratic formula. So here we go. When you have standard form, the first coefficient is the a value, so our a value is 1. The second coefficient is our b value, so b equals 4. And the third coefficient, or the third constant in this case, is 3, so our c value is 3. Okay, we're going to write out the quadratic formula. That is worth a mark. So when you have this on a test, you get a mark just for writing down the formula. So it's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, there's our formula. When I sub this in, just watch your b value. In this case, our b value is positive 4, so that's all right. That's not going to change the sign. When it's a negative, though, you're going to have two negatives, and it'll change to a positive. B squared is 4 squared. Subbing in our a value is 1. Our c value is 3. And that's all over 2a. Okay, we're going to start simplifying this. This is not the prettiest formula, so just make sure you go slow and pay attention to signs. I like to sub all this stuff under the square root into my calculator at one time. So 4 squared minus 4, bracket 1, bracket 3 is 4. 2 times 1 is 2. Not in love with that 2, so I'm going to redo it. Taking the square root of 4, we actually get 2. So I end up something like this. This is called the exact answer. Okay, this is the exact answer. I haven't rounded anything, I haven't calculated anything, that is my exact answer. When I find the approximate answers, I am going to use this fact that there's a plus and a minus to give me two separate answers. This is actually going to have two x-intercepts. So for my first one, it's going to be when it's a plus 2. And then my second one will be when it's minus 2. So if I were to solve this, negative 4 plus 2 is negative 2. Divided by 2 is negative 1. And the second one, negative 4 subtract 2 is negative 6. Divided by 2 is negative 3. So my two x-intercepts, or zeros, or roots, would be negative 1, negative 3. Let's just look at the top to see if that's the answers we got. Yes. If we would have factored it, it would have equaled negative 1, negative 3. So why didn't we just factor it and find the x-intercepts that way? Wouldn't that have been a lot quicker? Absolutely, it would. However, there are times when you're not going to be able to factor something. So there's a few reasons why you wouldn't be able to factor it. Either the numbers are going to be decimals and you just couldn't think of the two numbers that could be multiplied to give you the last term and added to the middle term because there's some crazy decimal numbers, or there may not even be any x-intercepts. So if it's not crossing the x-axis, you may not be able to factor it. Use the quadratic formula to show that there's going to be a negative under the square root. Okay, let's look at the next one. Again, if we could factor this, which we can, I can see this as a perfect square. How do I know that? Because I could take the square root of the two outside terms. So perfect square ends up looking like a bracket squared. You take the square root of the first term, first sign, square root of the last term, which would mean my x-intercepts are negative 5, negative 5. So it's actually only crossing the axis once. It's crossing at negative 5 and it's opening up. So this is actually at negative 5. Okay, so that's kind of what it's going to look like. Let's try to get to that answer using the quadratic formula. So first step, we're going to write down our a, b, and c value. A is going to be 1. Our b is the middle term, it's plus 10. And our c is plus 25. We're going to write out the formula just to get a mark here. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And we're going to sub in our values. This is negative 10 plus or minus. I'm going to put a 10 in here. Minus 4ac all over 2a. So we're going to simplify. Under the square root, again, I'm just going to plug that in my calculator. 10 squared, subtract 4, bracket 1, bracket 25. You get 0 over 2. Taking the square root of 0, we actually get 0. So it doesn't matter if you add 0 or subtract 0 from negative 10, you're still going to be just left with negative 10. So we have one answer, x equals negative 5, which means it's only crossing the x-axis at one point. That would be negative 5, and that happens to be the vertex as well. Just double check with our above. X equals negative 5. So this is correct. Again, if you can see that you can factor this, my goodness, by all means, go ahead and factor it and find the x-intercepts that way. We're just going to get to the point where that's not going to be able to be possible for some. So let's look at the back. We have 3x squared minus 2x plus 5 equals 0. Let's just see if we can factor that first, because that would be easier. It's definitely not a difference of squares or a perfect square. We can't common factor it. It's not a simple trinomial because we got a number out front. So this is a complex trinomial, which would mean we'd have to do decomposition. So we'd be looking for two numbers that multiply to AC. So we're going to multiply the two outside terms as 15 and add to negative 2. So two numbers that multiply to 15 add to negative 2. Two numbers that multiply to 15 would be 5 and 3. If you add them, you get 8. If you subtract them, you're going to get positive 2, not negative 2. So there actually aren't any numbers that would multiply to positive 15 and add to negative 2. This is where we have to use quadratic formula to solve this. So let's try. A equals 3, B equals -2, our C value is 5. We're going to write out the formula. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. So you get a mark for the formula. You're going to get a mark for subbing it improperly. So I have a negative. Just watch here, your b value is negative this time. So 2 negatives, those are actually going to turn into a positive. Oops. Okay, so 2 negatives turn into a positive. I'm going to sub in everything under the square root in my calculator at one time. So we're going to have -2 squared, subtract 4 bracket 3 bracket 5. This is -56. You can already see we have a problem. What is the problem? Whoa. Problem is we have a negative under the square root. You cannot take the square root of a negative number, so there's no solutions. There's no possible value of x that's going to make this equation equal to 0. So there's no solutions since we cannot take, oops. We cannot take the square root of a negative number. So what does this mean? It means if we were to graph this out, it would just never cross the x-axis. And that's quite common. Does it match what we had when we were trying to factor it? Yes, we couldn't factor it. It's actually because there was no x-intercepts. So sometimes when you can't factor it, it's because the numbers are decimals. Sometimes it's because it's just not factorable. There are no values. So let's try the next one. Again, let's try factoring this first to see if it works. It's a complex trinomial because it's 3 terms and it's got something out in front. We can't common factor it at all. So we're going to try to find 2 numbers that multiply to give us AC, which is -21, and multiply to give us the middle term, which is 10. I'm not liking that 10 here. 2 numbers that multiply to -21 would be -7 and 3. Is there any possible way we can get those to add to 10? No. If it was +7, +3 would work, but it's not. Okay, so there is no 2 numbers. So either it's not crossing at all or it's crossing at some decimal numbers. I'm not going to know until I actually try to solve this with the quadratic formula. So write down your A, B, and C values. Write down the formula. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. We're going to sub in what we know. I know b is 10. I know a is 3. And c is -7. We're going to simplify as much as possible. So I'm going to plug in everything under the square root at one time in my calculator to get 184. Square root of 184 is actually not a nice number. So this is going to be my exact answer. When I put in this decimal number, it's going to turn into an approximate answer because all of a sudden I've started rounding it. Square root of 184, we're going to use 13.56. So it's actually 13.56465997, and that's the only decimals that are in my calculator. However, I bet there is more. That means all of a sudden it's approximate. It's close. It's not exact, but it's close. So this is approximate. Just in case the textbook ever wants an exact answer, they want the square root there. Okay, so because I have a plus and a minus here, I'm going to end up with two different answers. One where it's plus, and one where that's a minus. So if it's a plus, I'm just going to punch that into my calculator. We're going to get 0.59. And if that's actually a minus, we're going to get negative 1.19. Okay, so two possible answers. Those are just the two different, oops, I made a mistake here. Where's Reese to correct me? I forgot the negative on the 10. This is negative 10. Subtract 13.56. Okay, so I'm going to throw that into my calculator again. Negative 10, subtract 13.56. We get negative 3.93. Okay, that looks better. So two different answers, two x-intercepts. It actually does cross the x-axis. We just couldn't factor it because they're not nice whole numbers. They're at decimals, and that's going to happen a lot too. So using the quadratic formula, we can always find the x-intercepts even if it's factorable. Example 2 is just a refresher on how to determine the roots of the equation given vertex form. When you're given vertex form, all we're going to do is isolate the variable. So we talked about this yesterday. Vertex form, we're going to isolate the variable. So what a lot of people end up doing is expanding this to standard form and then using quadratic formula. That is a ton of extra work where you could have just started moving things over and solving for x. So if we do a quick sketch, I know my vertex is going to be negative 5, 2. That's my HK. So negative 5, 2, which means you're going over negative 5 up 2. And it's opening down because we have a negative out front. So I know it's going to look something like this, which means it is crossing the x-axis twice. We just need to figure out what those two numbers are. So if I want to isolate this, I want to start moving things over one at a time to get x by itself. The first thing you're going to move over is that plus 2. Move that across. It's going to become negative 2. Next step, you're going to do your division. So divide by the negative 2 so that these cross out. You're left with x plus 5 squared equals 1. Take the square root of both sides. Don't forget the square root of 1 we've learned is positive or negative 1. So it could be negative 1 squared is positive 1 and positive 1 squared is positive 1. So we got two answers here. In our last step, we need to move that 5 across to become subtract 5. So we're actually going to end up with two answers here. One of our answers is when it's a plus 1, which is negative 4. And our other answer is going to be when this is minus 1, which is negative 6. So our two x-intercepts here are negative 4 and negative 6. Okay, so you don't have to expand that to standard form and then use quadratic formula. That is a lot of work. Will it work? Absolutely. You'll get the right answer. However, just a ton of extra work. Okay, next page. You can use quadratic formula to determine how many roots a quadratic has without actually solving the equation. So sometimes the question doesn't actually want to you to find x. They just want to know, is there going to be an x value that satisfies this equation? And if so, is there one value, is there two values, or is there zero values? So don't forget, another word for roots is x-intercepts, or zeros, or even solutions. Is there going to be a solution? So is there a value of x that will satisfy the equation? So we're going to talk about something called the discriminant. The discriminant is b squared minus 4ac. You'll recognize the discriminant because of the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So where do you see the discriminant? Under the square root. Okay, so discriminant is under the square root in the quadratic formula. if that discriminant is greater than 0. So if you have a number bigger than 0 under the square root, there is going to be 2 distinct real roots. Okay, distinct just means unique, 2 different x-intercepts. So it's crossing the x-axis at 2 different spots. So if the number under the square root ends up being bigger than 0, there's going to be 2 x-intercepts. If d equals 0, there is 1 real root. There is 1. So if you get a 0 under the square root, you're not going to get that plus or minus number because it's the square root of 0 is just 0. So you end up with 1 answer, 1 x-intercept, which actually ends up being the vertex. And if d is less than 0, there are no real roots. So if you get a negative under that square root sign, it's just going to tell you that there is no answer. There's no x-intercept. It's never going to cross the x-axis. Either it's starting above it and opens up, or it's starting below it and opens down. So that happens a lot too. All 3 of these are going to occur. You're going to see all 3 of these happen. What does the word real mean? Well, eventually in your mathematic careers, you're going to find out that there are things called imaginary numbers. And I will just tell you that an imaginary number, is actually the square root of -1. So right now we talk in real numbers. We talk in 1, 2, 3, 4, 5. But in order to do some proofs in math, in order to solve some problems, they've invented this imaginary number, which is actually the square root of -1. So when they're talking about real, they just mean there's no imaginary number because there's no square root of -1. But in math terms, they've created one just so we can solve some problems. Some really smart people there. So real roots, real numbers. Determine the number of zeros for each equation. Okay, we're given standard form here. I just want to figure out, is there going to be a solution? I don't care what the solution is. I don't need to know what the x-intercepts are, if there are any x values that would work for this. I just want to know, are there any? So we're going to use our a value is 1. Our b value is 7. Our c value is 15. And I'm just going to sub that into my discriminant. So what would be under the square root sign? So under the square root sign of the quadratic formula is b squared minus 4ac. If I sub in my values here, you're going to get 7 squared minus 4 times 1 times 15. And again, just plug that all in your calculator in one step. You're going to get an answer of -11. So what does that mean? There are no real roots. There's no x-intercepts. So since d is less than 0, there are no real roots. There's no possible value of x that's going to satisfy this equation. Okay, if I draw a little picture for you, it would end up looking like this. Next one. Y equals -20x plus 4x squared minus or plus 25. Don't let them confuse you. It's not written properly in standard form. So they've mixed up the a and the b value. Put your x squared term first, then your bx, then your c. So a is actually 4, b is -20, c is 25. We're going to sub that into the discriminant formula, so whatever's under the square root in the quadratic formula. Sub in our values for a, b, and c. If I punch that in my calculator, I'm going to get a lovely answer of 0. So since d equals 0, there is exactly 1 real root. 1 distinct real root. So if you're to look at an example of that on your graph, what would that look like? It just means there's 1 x-intercept, which is actually your vertex. And the last one, they haven't mixed this one up on us, so that's good. A is 1. B is 3, C is negative 5. We're going to use our discriminant formula to figure out if there's going to be an x-intercept here. Plug all that into your calculator, you're going to get a lovely answer of 29. So since that is bigger than 0, there's going to be 2 real roots. Which means it's crossing the axis at 2 spots. So if we think of the graph here, it's going to end up crossing at 2 spots. Last page, the direction of opening and the position of the vertex also determine how many roots a graph and its corresponding equation has. So if you're given vertex form, it's super easy to see if it's going to have 2 real roots, 1 real root, or no real roots. If the vertex is, say, up here in this quadrant and it's opening down, you can see it's going to have 2 real roots. Or if it's over here and opening up, you'll be able to see it has 2 real roots. If the vertex is on the x-axis and opening up, it'll have 1 root, and opening down will have 1 root. And then there's times where the vertex is going to start up above the x-axis and open up. There'll be no real roots, or it could start below and open down. There'll be no real roots. So again, there's tons of possibilities. There's like an infinite number of possibilities of how a parabola is situated and whether it opens up or down. So you'll be able to find out if it crosses the x-axis 0 times, 1 time, or 2 times. So let's just look at some in vertex form and try to figure out how many times it's going to cross the x-axis, how many roots it's going to have. So negative 2 x plus 1 squared. The vertex of this is hk. So vertex for the h value, you're going to switch that sign. The k value is on the end. So in this case, it's 0. There's no k value. So if I were to think of this, it's negative 1, 0. That's my vertex. And it's a negative, so it's opening down. So is that crossing the x-axis 0 times, 1 time, or 2 times? In this case, it is once, so 1 root. Next one, vertex is going to be negative 3, negative 2, so vertex is hk. So negative 3, negative 2, my vertex is going to be down here. In this case, my a value is positive, so it's opening up. So how many times did it actually cross the x-axis? Twice. So there's 2 roots, 2 solutions. Next one, vertex is going to be positive 2, negative 7. So if I were to sketch this out, positive 2, negative 7 is actually down here. It is opening down because I have a negative out front, so it's opening down. So how many times is it actually crossing the x-axis? None. So no roots. And the last one, the vertex is hk, so this is negative 2, 0. There is no k value, which means its vertex is here. It's opening up. So how many roots does this have? How many times does it cross? Just once, right at the x-axis. So therefore, 1 root. All right, let's look at an example here. The profit of a small company is modeled by the quadratic relation, where P is the profit in dollars. Is it possible for this company to make a profit of 10,000? So here's my equation for the profit. Is it possible to get a P value of 10,000? So if my P is 10,000, that's exactly where I'm going to sub it into my equation. This is the P. I'm going to put it in for the P. So we're going to put 10,000 equals negative 25x squared plus 402x plus 5,000. In order to solve this, I want that left side to equal 0. So I need to move that 10,000 over to the other side. So leave that as 0. We're going to move the 10,000 over here. So we're going to subtract it. And then let's simplify that. So this is going to be negative 5,000. If I want to figure out if this is actually going to have a solution, is there any possible value of x for that side to equal 0? I'm going to write down my a, b, and c values. And I'm going to use the discriminant to figure out, is there a solution? So it doesn't actually want me to find the solution. It just wants to know if it's possible. Is it possible? So let's see. I'm going to substitute our values in here. We're going to plug this in our calculator to get an answer of -3.38396. I just want to double check that my calculator 402 squared. Yes. Okay, so because the discriminant is less than 0, what does this mean? So since our discriminant's less than 0, there's no solutions. There's no way we can make this work to get a profit of 10,000. Therefore, it's impossible to make a profit of 10,000. Okay, here's the homework assigned. 2AC, you can check this with Desmos. So if you want to go on desmos.com, you can actually just plug in your equation there and check the graph to see if your answer is correct. If you have any questions, make sure you log on to D2L, to our team's meetings when we take up this homework.